Here we have a question. In this question, we have to find the displacement of crate to attain a speed of 6 meter per second. So as we can see here, there would be three forces acting on the crate along horizontal direction. One would be the component of this force, second would be the component of this force, and the third is friction force, which is acting in opposite direction of the motion. So first of all, let's understand what's going to happen here. The box, or we can say the crate, is initially at rest. Means we can say that the initial kinetic energy is zero. And after some time, as it travels some distance under these forces, its speed becomes 6 meter per second. So we can say that the speed, or we can say the kinetic energy, is achieved by the work done of these forces. First of all, we'll calculate the net force which is acting along this direction, means along horizontal directions. From here we can write net force into displacement will be equal to work done, which is equal to kinetic energy at 6 meter per second. This is one of the method, or in other method we can calculate individual work done by these forces. We can calculate work done by this force, we can calculate work done by this force, and we can calculate work done by the friction, and from there we can add them, and that is equal to our kinetic energy, which we can calculate kinetic energy as half of m into v square. Let's substitute the value of m as 100 and the value of v would be 6 meter per second. So from here we can calculate the value of displacement. So first of all, let's understand how can we calculate the work done by these forces. Work done by these forces will be equal to force into displacement along the direction of force. So from here we can calculate the value of work done by force. So as we can see, this is resting on a flat which is having a friction coefficient of 0.02. So from here we can say that the work done by the force will be only by the component of force along the direction of motion. So from here we can write the component of this 100 Newton force along horizontal, that would be written as 100 into 4 divided by 5, and if we multiply it with the displacement d, this would be the work done by this force along horizontal direction. So here we can calculate this also using the same method, but how can we calculate the friction force? We are given the coefficient of friction force, but how can we calculate the value of friction force? The value of friction force can be calculated as normal force into coefficient of friction. So from here, as we know, we are given the coefficient of friction, we have to calculate the normal force. For that, we will equate all the vertical forces. As we can see, the weight is acting in downward direction. As we can see, the component of this force along vertical direction is also acting in downward direction. The component of this 100 Newton force along vertical direction is acting in upward direction. And as we know, the normal force is always from the ground in upward direction. So we can balance this force in order to find the normal forces. So from here we can calculate the value of normal force. As we multiply it with the friction force, we can get the value of friction force as we multiply normal force with the coefficient of friction. Now let's try and understand why the work done by friction force would be negative. As we know, the friction force is opposing force to the direction of motion. So we can say that friction force is acting in opposite direction of the motion. So the displacement would be having minus sign. So from here we can say that the work done by friction force would be negative. So first of all, let's move forward. Let's see what's given to us. The coefficient of friction is given to us, which is mu k, which is 0.2. The final speed is given to us, which is 6 meter per second. So as we discussed, the value of F1 is 800 Newton and the angle is given to us, which is 30 degree. And the value of force F2 is given to us, which is 1000 Newton, as you can see here. And the value of slope is given to us, which is 4 divided by 5. So now let's move forward and calculate the value of normal force. For that, as we discussed, we must know the value of N. So this would be our friction force, which is F equal to mu K into N. Now let's move forward. We can write the value of work done by the force F. That can be written as F into cos theta into displacement along horizontal direction ds. So as we integrate this, we can write it as F cos theta into S2 minus S1. This would be our work done by force 1 for going from position 1 to position 2, and this would be our work done by friction force. So now, as we know, we can write the value of kinetic energy as half mv square. So now let's apply the principle of work energy, that energy is always conserved. So here we can see the initial kinetic energy plus the work done will be equal to final kinetic energy. So here, as we know, horizontal force components, the horizontal component of force F1 and F2 is acting in the direction of the displacement for of cart, which does positive work as we discussed, while the friction force does negative work. And in vertical forces, the vertical component do not create any displacement along vertical direction. So the work done by the vertical forces will be equal to 0. So here as we know, we can write the summation of vertical forces, which is equal to 0. We can write it as n minus f1 sine 30 plus f2 into 3 divided by 5 minus mg will be equal to 0. So as we equate it equal to 0, we can write the value of normal force, that comes out to be 781 Newton. Now from here, as we know the value of normal force, let's multiply it with the coefficient of friction, which is 0.2. So from here we can write the value of friction force, that comes out to be 156.2 Newton, but it's in backward direction. So here let's calculate the work done by the horizontal component of this 800 Newton force, which will be equal to 800 into cos 30 into ds. So as we integrate this, we can write the value of work done by this 800 force along horizontal direction as 692.82 into S2 minus S1 joules. Now let's find the work done by this 1000 Newton force. So here, as we can write it as 1000 into 4 divided by 5 into ds. So here the limits are S1 and S2. So from here we can write work done by this 1000 Newton force along horizontal direction would be equal to 800 into S2 minus S1 into joules. So here, now let's move forward. We have to calculate the work done by the friction force. As we know, the friction force is acting in opposite direction of the direction of motion. So from here we can say that the friction force will be considered as in this direction. So from here we can write the work done by friction force, that is 156.2 into S2 minus S1. Here as we can observe that S2 minus S1 is common in all work done. So from here we can take it common, and this is equal to our displacement D. So here let's substitute the value of T1 equal to 0 in equation number 6. So from here we can write the value of T2. First of all, let's write the value of T2, that is half of mv square, that is mass is given to us of the crate, that is 100 into the speed square, which is 6 into 6. So from here we can write the value of T2, means the kinetic energy of this crate at second position, that is 1800 joules. So We will equate with it with the total work done. So first of all, let's write the total work done, that is equal to work done by force of 800 Newton along horizontal direction plus work done by the 1000 Newton force along horizontal direction minus work done by the friction force. That comes out to be 1336.62 S2 minus S1 joules. So as we equate with it with 800, 1800 joules, we can find the value of S2 minus S1. That comes out to be 1.35 meter. Hence, we can say that the displacement of the crate to attain the velocity of 6 meter per second under the influence of these forces is 1.35 meter. Thank you.